Hello and welcome to Advanced Java Programming with Java at Portland State University. In this screencast, we'll learn about some of the fundamental tools for working with Java and take a look at getting started with a basic Java program. So more specifically, we're going to learn about some of those fundamental tools for working with the Java programming platform and then walk through building a simple Java application. When we're done, I hope you're able to first identify several of the key tools for developing Java applications, and then begin to start editing and building a functioning Java project. A fundamental tool for working with Java is called the JDK, the Java Development Kit. The JDK consists of several components. First, there's the compiler for the Java language. There's the Java virtual machine, which runs your Java applications. There's a suite of standard libraries for the Java programming language and the programming platform. And there's also tools like JavaDoc, which is a tool that generates readable documentation for your code. You can download the Java Development Kit from the URL here on the slide. You'll also get information on that URL for how to configure and install the JDK on your machine. Once you've installed the Java Development Kit, you can make sure that it's installed correctly by issuing a couple of commands. If you're on a Unix-based system like Linux or Mac OS, you can do the which Java command to make sure that the Java command is found in the location that you expect. And you can also run the Java virtual machine, saying java-version. That will tell you which version of Java is being run. These two examples here come from the CS department's Linux machines, linux.cs.pdx.edu. Another tool that we'll be leveraging extensively in this course is Apache Maven. Now, Maven is a build tool that itself is written in Java that provides conventions and configurations for building standard Java projects. So Java is more than just a bunch of source code. There might also be things like third-party libraries, source code and unit tests, and things like images that you might want to include in your application. Apache Maven specifies standard format for projects and also a number of utilities for the entire lifecycle of your project, compiling the source code, running unit tests, bundling it into various artifacts that can be deployed. You can learn more about Apache Maven by going to the URL referenced there. That will tell you how to download and install Apache Maven on your system. To learn more about Maven and all of the various things that it can do for you, I recommend the lecture notes that are referenced there on my website. After you've downloaded and installed Maven, you can make sure that it's installed in the place that you expect and configured correctly by first of all looking for the command on your path using a command like which on Linux-based systems. And then you can run the Maven command with a -version option, which will tell you which version of Maven is being used and also the version of Java that's being used underneath the covers. Again, these two examples come from the CS department's Linux machines, linux.cs.pdx.edu. Another tool that I highly recommend using for working with Java is an integrated development environment, an IDE. And so hopefully you're familiar with what an IDE is. It's basically a very nice visual editing tool that will help you not only edit your source code, but then work with the entire life cycle of your application, running automated tests, perhaps building artifacts. It's a nice user interface on top of a tool, or in addition to a tool like Apache Maven. I personally recommend IntelliJ, the IntelliJ IDE by JetBrains. I think it's very powerful, and even though it is technically commercial software, they do have a free community edition, and as a student, you're entitled to an academic license for the Ultimate Edition, which gives you not only IntelliJ, but really access to the entire suite of tools from JetBrains. So even though you'll be working with Java and IntelliJ in this course, there are also some really nice Python editors, C# editors, JavaScript editors that are available through this program. Now, if you're familiar with another IDE, such as Eclipse or NetBeans, those are fine to use for this course. I guess the thing is, I personally am not that familiar with those IDEs, and so then if you need help, you'll have to look on the internet or work with one of your other students to get your questions answered. But anyway, I highly recommend using an IDE. It'll make your life a lot easier. Okay, now that we've learned about some of the fundamental tools that are used with Java, let's take a look at a simple Java project. We started with building a simple student application, and we'll see how we can use Maven to create the skeleton of the project. We'll then, after running some Maven commands, open up IntelliJ and look at what the code looks like in there. and then also use both IntelliJ and Maven to run our unit tests and our integration tests to make sure that our code works properly. All of this comes from the student project from the course's website. Great, and so here we are. I'll make it a little bigger. So the student project is a very simple sort of one-class project that's meant to help you get used to working with someone else's code and really work with this fundamental tool set. Notice this is called Project Zero for the class. This is an optional project, and I use an example to get started with the tools that we'll be using for the course. You can read more details about this on the course's website, but I do want to point out that once we run what's called a Maven archetype, you'll get a simple class called Student, which extends one of my classes, Human. It's got a constructor, it's got some behavior associated with it that we'll take a look at in the source code and in the automated tests. Now, to get started with this simple student project, there's something called a Maven archetype that will create the fundamental project layout for this project. You can learn more about a Maven archetype in the lecture, but for the purposes of this, what you need to know about an archetype is that it's a way of creating a project. And so you run a command line, and what that does is that goes off and gets the archetype. Then it begins to create a project. It'll prompt you for some information about that particular instance of the project that you're creating, basically some information about who you are and what version you want the project to be. And then it lays out a whole bunch of files and directories to get you started. In order to use the Maven archetype for this project, you need to do some configuration on your system. You need to add something called a settings.xml in the .m2 directory. I'll show you that in a moment, but first what I want to do is show you when you don't have that configuration. So if for some reason you forget to do this step, or you're seeing certain behavior that you don't understand, I want to show you how you can remedy that behavior by adjusting your settings.xml. So I'm going to scroll down here to the actual Maven command line. So MVN stands for Maven, and the way you create a new project from an archetype is that you use this command line right here, which specifies that first of all, hey, I want to generate a project from an archetype, and then you're going to tell it the group ID. All artifacts in Maven have something called a group ID, which identifies sort of the organization that produced the archetype, and then the ID of the artifact, which is the archetype that you want to then instantiate in your own project. So I'm going to copy this command line over to a console window that I have open to the computer science department's Linux machine, linux.cs.pdx.edu. I'm using this here as an example. I recommend that if possible you do the bulk of your development on your own machine, but it's very important to make sure that your code does run on the CS department's Linux machines, because that's where I grade your code. So even if it works on your machine, well, it's got to work on the CS department's machine in order for me to be able to grade it. Okay, so we're going to paste that command, that Maven archetype command, hit return. So one of the things that Maven provides is management of lots of third-party dependencies. By third-party dependencies, I mean code that your code needs that you didn't write. So when you run Maven, the first thing it does is it downloads a lot of stuff from repositories that are out there on the internet. A lot of the stuff you saw scroll by, these are libraries that Maven itself needs to use. So these are libraries for various what are called plugins, things like compiling the Java code, or in this case, working with archetypes. So it went through and it did a bunch of that. And where it got to is the following. When you go to create an archetype, there are hundreds of archetypes out there for all sorts of different kinds of projects, different kinds of Java projects, different kinds of projects that are all based on the JVM. And it was looking, and we told it to look for my archetype, and it couldn't find it. And that's because there was that configuration step that we didn't go through that I'll come back to very shortly. So if you see this behavior, if you try to create the archetype and it's telling you essentially that, hey, I can't find the archetype that you told me to look for, here's 1,800 other archetypes that you could use, we could talk later about if this is the right behavior or not. This means that you're missing some configuration. You should Control C out of this and go back and fix it. So I don't want to create the archetype right now. Instead, what I want to do is go back to what it said in the project assignment. So there is some configuration you need to do you need to put into a file called settings.xml, which resides in your .m2 directory. So I am going to let's use vi. I say .m2 directory. This is in my home directory, so on Unix-based systems it's tilde. On Windows it'll be whatever your Windows user home is set to, and it'll be called settings.xml. And these are settings for Maven. And what you need to tell Maven is, hey, in addition to looking for artifacts and specifically archetypes in the central repositories out there on the internet, there's one that you need for this class, and that's my repository. And I host it on a service called BinTray. You can go off and read about all the details about what all this XML means off on the Maven website if you are so enthused. Can't say that's terribly exciting. But anyway, basically what you're telling it is you create something called a profile, and that doesn't indent the XML very nicely. And you create something called a profile, which will be active by default. And this says, hey, when you're looking for artifacts, look in Dave's repository too, in addition to the standard ones. So I'm going to write that file out. And now, when I go and I run my Maven command again, you'll notice that I won't download as much stuff as before because, well, it caches everything locally also in that .m2 directory. Notice what it does download then are all the information from my bin tray for the student archetype. And here again, you can learn more about what POM files are, what jar files are, in other parts of the lecture. So it's asking you for something called a group ID, and here in the assignment it talks about what we should do there. The group ID is basically something that identifies you and the group that you work for. For this course, we're going to call it edu pdx cs410j, and then just your login ID. My login ID is Whitlock. The artifact ID, every Maven project creates something called an artifact. We're just going to call ours student. That'll be the name of the project. And then the version, by default, it's 1.0 snapshot. That's fine for us. Other places, you'll see that I've created archetype versions, artifact versions that correspond to the term the course was offered. For this one, just leave it 1.0 snapshot. And that's also going to ask you for the value of your Java package. I like to use that the same as the group ID, so it'll just be edu pdx cs410j Whitlock. Ask you to verify all of that stuff. That is correct. Great. And now what it's done is it's created a directory called student. And within that student is the information that you need to get started. There's something called a pom.xml, which describes the project itself. And there's also a source directory that contains things like your source code. And this is source code that has been generated by the archetype as a place to get started. So we want to make sure that our Maven project works. The way you can do that is by using the command maven verify, which will run the verify phase of the Maven project. And you're going to see a lot of stuff go by, and I'll talk about what it's doing. So what Maven verify does is it runs the entire life cycle of your project, starting with compiling the source code and then running your unit tests and then building the artifact, in this case, so it's called an executable jar file, and then running integration tests, and finally, I guess that's it. The last thing it does is it runs the integration test and verifies that the integration tests are complete. What you're seeing go by here on the screen is downloading all of the stuff that the project needs to do its work. So lots of things that Maven needs, lots of things that the the application needs. For instance, it needs libraries for doing unit tests, some other libraries for integration tests, stuff that I've written and stuff that is third-party there on the internet. And you can see ultimately the build was successful, meaning that I was able to compile everything and run all the tests, and none of the tests failed. That's cool. Another command that's useful is Maven package, and what this does is that this will create what's called an executable jar file. A jar file is basically a collection of executable Java code that is the main command line for your program. So if you say java-jar, and the jar file you want is in the target directory, and it's student 1.0 snapshot. If you run that, it actually ran the program and told you that there were missing command line arguments to the program, which is exactly what you'd expect it to do if you took a good look at the source code. Over here in the assignment, it talks more about what you'd expect, and one of the things that we'll do in class is spend some time building this application using test-driven development so that you can see more about Java and more about how to use tools like Maven. The final thing that I want to take a look at in this screencast is briefly looking at importing this new project that you created with the Maven archetype into IntelliJ so that you can edit the source code more easily and then work with your project through IntelliJ in addition to Maven. So I've switched away from using the CS Department's Linux machines to working here on my local environment. Attempting to run IntelliJ on source code that lives on a remote system would be challenging and problematic and probably wouldn't even work. So for this example and for much of what we see in class, I'll be running from my local machine. I've got here my project that the Archetype created. So I'm going to switch over to IntelliJ, and I will import the project there by saying File, New, Project from Existing Sources. I've already got some project sources that I want to import, and here is the directory. I'm going to select the pom.xml that was created, and it brings up an import menu for importing it, and I think all the defaults are correct. What you're seeing in the background is some other code that I was editing. So we want that profile that we created. Yep, we want to have that be active, and that is the artifact for the project that we want to import. And now we need to select which JDK, or they call it SDK, they want to use. I've got a bunch installed on my machine, including some really old ones and some Android stuff. What we want the latest is 1.8. You may need to customize your own JDK by pressing this plus button here. That will add a new SDK right there. But if you've already installed Java on your machine, it should be able to find it. Tell it that you want to use Java 8. And finally, yep, the name of the project is student, and that's where we want to put the student files. It'll ask, do you want to open in a new window? Say yes. Okay, great. And now you can browse your source code here in your project. And so here is the main class, again, a very simple student method with all sorts of information here, including a main. And in IntelliJ, you can do things like run your main method by clicking the little the go method, the go button right here. So you can run that. It'll build your project, make sure everything compiles, and then run it, missing command line arguments, which is exactly what we saw when we ran it from the command line before. Something that went by pretty quickly on Maven was the running of the unit tests. So here we have a unit test called student test. We'll learn more about unit testing and JUnit very shortly in the course, but you can run individual tests here in IntelliJ. You can also run all of the tests in a given class. And so here again, it'll compile all the code, it'll run everything, and it will tell you that here, all tests pass. You can also, let's see here, there's also a way to show, oh, there we go. You can show the individual names of the tests that pass. Normally when your tests pass, you don't really care that much. You care more about the tests that failed. So you've got unit tests here, and then you've also something called integration tests, IT, which are tests that instead of exercising just a little piece of functionality, exercise several pieces of functionality, maybe multiple classes working together, something that requires both a client and a server. We'll see lots of examples of this stuff all throughout the course. But you can run those here also. And right now everything's passing, which is really good. And so then what we'll be doing in the first couple of weeks of the course is working through this simple student project using test-driven development to build out more of the functionality and make sure all of that functionality passes. So that's it. That was a quick overview of some of the fundamental tools that we'll be using in this course to learn about advanced programming using Java. We saw the Java Development Kit. We got a brief introduction to Apache Maven, and we saw quickly how ideas IntelliJ can be used to work with Java projects.